Welcome back, game developer hobbyists! In the last episode, we completed the basic version of the Snake game. Now we're going to give the player some extra variety by adding a series of menu options to customize gameplay. The first game option we'll be adding is snake speed, which we'll measure in tiles per second. To get this going, we'll first need to add a menu system to the splash screen. The main menu will start out with 3 options: starting a game, changing game options, and exiting the game. I'll be going through this one commit at a time so that you can see my progression during development. First, we need a way to define the available menu items. The splash menu item type enumeration lists the type of menu items we'll need: actions, sliders, and button options. Actions just perform some function. Sliders allow the player to adjust some particular value within a range. The splash slider range struct will be used to define the minimum and maximum values allowed. I wanted to be able to display some fun descriptive text along the bottom of the screen as the player adjusts the slider. The splash slider range description definition struct lets us define separate descriptions for each range of values. Button options allow the player to choose between distinct options. The splash button option definition struct gives each option a unique identifier, the display text on the button itself, and descriptive text to appear on the bottom of the screen. The splash menu item definition struct provides the complete definition of a single menu item. It has a unique identifier, the type of menu item, the display text of the menu item, and descriptive text to appear on the bottom of the screen. For sliders, it also defines the full slider range, and a list of descriptions for ranges of values. For button options, it also defines an ordered map of the available button options. The splash main menu ID namespace will house the unique identifier constants for the main menu items. Similarly, the splash quick game options menu ID and splash quick game option values namespaces are for quick game option menu items. The Splash Menu Factory namespace will provide utility functions used to build our menus. Over in the Splash Menu Factory source file, we have some additional namespaces for the labels. The Splash Main Menu Labels namespace houses the labels and descriptions for the main menu, while the Splash Quick Game Options Menu Labels namespace houses them for the quick game options. A series of convenient utility methods will be used to create menu item definitions, slider ranges, and button options. The Create Main Menu Definition Map function is used to build the main menu. We have an action item to start a quick game, an action item to switch to the Quick Game Options menu, and an action item to exit the game. The Create Quick Game Options Menu Definition Map function is used to build the Quick Game Options menu. We have an action item to return to the main menu, and the Snake Speed slider. The Create Snake Speed Menu Item function is used to build the Snake Speed slider. It starts out by creating an empty slider, then sets the label and descriptive text. Then it adds 4 descriptive ranges for slow, normal, fast, and blazing speeds. Now that we have a way of defining menu items, we also need something to maintain the current state of the menu item values. This will be achieved by the Splash Menu class. It stores an ordered map of menu items and a map of the currently chosen values. It also keeps track of which menu item the player is currently interacting with. We have methods to change the current menu item, and another set of methods to change the current item's value. These will be called later when we process keyboard and mouse events. With all of that in place, we can now focus on actually adding our menus to the splash screen. The new splash scene mode enumeration will be used to keep track of which menu the player is currently interacting with. In the splash scene controller, we've added internal variables for the mode and the 2 menus. These are initialized accordingly in the constructor, defaulting to the main menu. To get this on the screen, we've added a menu argument to the render method on the Splash Scene Renderer class. A new set of constants define where the menu will appear on the screen, how much space each item will use, and where the descriptive text will appear. The Splash Menu Item Render State struct will be used internally by the renderer to draw each menu item. The Render Menu method takes care of all the drawing. It first sets up the render state for the first menu item, then loops through the menu items to draw each in turn. The Resolve Highest Menu Item Width method is used to figure out the widest menu item. In this commit, I wasn't yet concerned with drawing the sliders, so the logic only needed to determine the widest display label. The Render Menu Item method is used to draw a single menu item. If this is the menu item the user is currently interacting with, we first draw a transparent rectangular background to visually indicate focus. In such a case, we'll also draw the display label in yellow instead of white. We then go ahead and draw the display label itself. Further to this, we also draw the optional descriptive text at the bottom of the screen. With the menu items drawing on the screen, we now need to handle the user interaction. In the process event method of the splash scene controller, we'll need to handle events from either the keyboard or the mouse. First, looking at keyboard events, we've created a separate method to handle the main menu and options menu. The splash menu keypress result struct will be used to pass back information about menu item interactions from the keyboard. The process menu keypress event method is responsible for translating keypresses into this keypress result. By default, it indicates that no action is being requested by the player. Pressing space or enter while an action menu item is in focus will specify that the given action is requested. Pressing the up or down arrows will change focus to the previous or next menu item, respectively. The process main menu keypress event method is called specifically when the player is on the main menu. Similarly, the process quick game options keypress event method is called for the options menu. These two methods check if an action is requested by the player, and if so, perform the action. The perform main menu item action method translates the menu item identifier into a client request, which ultimately gets passed back to the game client. If the player wants to switch to the options menu, we change the splash scene mode and set the focus on the options menu to its first menu item. The perform quick game options menu item action method has a similar responsibility for the options menu. For this commit, we are only handling the return to main menu action. Next, we'll look at how mouse events are handled. The splash menu mouse position result struct will be used to pass back information about menu item interactions from the mouse. When the player moves the mouse, we'll potentially want to change which menu item is currently in focus. The SFML map pixel to coords method can be called to convert the mouse's position to the Windows view coordinates. As long as the left mouse button isn't pressed, we find out if the mouse is over a menu item. If it is, we change focus to it. The task of discovering which menu item the mouse cursor is over falls to the resolve menu mouse collision result method, found on the splash scene renderer. By default, this will return a result indicating the mouse isn't over a menu item. It loops over each menu item and checks if the cursor position is within its boundaries. If it is, then the result indicates as such. As a side note, I always find the C++ standard template library's map structure to have some rather odd naming conventions. Each item in the map is actually a pair. You refer to the key as first and the value as second. When the left mouse button is clicked while the cursor is over an action menu item, we'll want to perform that action. Similar to the mouse move events, we call the SFML map pixel to coords method to determine the cursor position. Then we call the renderer's resolve menu mouse collision result method to find out if the cursor is over a menu item. If it is, we perform the desired action based on the current menu. Now that we have the action menu items working, we can focus on getting the snake speed slider working. The slider menu items are going to need some extra space to display the slider. So the resolve highest menu item width method has been updated to factor this into the calculation. The render menu item method has also been updated to handle the additional logic for drawing the slider. For slider items, we want the display label to be left-aligned rather than centered. We then draw a thin rectangle for the horizontal part of the slider, and another thin rectangle for the vertical slider handle, whose position is based on the menu item's current value. If the slider menu item has descriptive text for the menu item's current value, we additionally display it at the bottom of the screen. In order to interact with the slider, we've also updated the resolve menu mouse collision result method. Two new properties have been added to the result to indicate whether the mouse cursor is over the slider. If the cursor is detected to be within the boundaries of the slider, we update the result accordingly. This should occur whether they are moving the mouse with the button held down, or just clicking the button without moving it. The process menu keypress event method will also update slider values if the left or right arrow keys are being pressed. With the player interaction of the slider in place, we now just need a way of telling the game to actually use the adjusted snake speed value. The quick game options definition struct will be used to keep track of all the optional gameplay values. The quick game controller now includes this as a private member variable, and provides a setter for it. The start game method now takes the snake speed from here, instead of a constant value. In the game client class, we just call the setter when we switch to playing the game. And voila! We now have a functioning menu system. The player can adjust the snake speed using either the keyboard or the mouse. And when they start playing, the snake will now move as slowly or as quickly as they like. The remaining commits for this task involved some refactoring passes on the code. The first refactoring was on the render menu item method in the splash scene renderer. There are now separate drawing methods for the focused menu item background, the menu item's slider, the menu item's descriptive text, and the slider value's descriptive text. The second refactoring involved updating the splash scene controller to manage its music in a manner that's consistent with the quick game controller. The third refactoring was on the process event method in the splash scene controller. There are now separate methods for processing keypress events, mouse move events, and left mouse button events. And the final refactoring was just a name change for clarity. Now that we have a fully functioning game menu, the remaining game options should be fairly easy to add. The next option we'll add is the size of the playing field. The Quick Game Options definition struct is first updated to include the field size. In the Quick Game Controller's start game method, we can now initialize the field size based on these values. We additionally set the snake's starting position based on this field size. In the Quick Game Renderer, we have some new constants that we'll use to guide how to draw the playing field. The new Resolve Viewport Tile Size utility function is used to determine how large each tile should be. To avoid rounding errors as much as possible during rendering, this function will restrict the possible tile sizes to ratios of powers of 2. In retrospect, I'm not actually sure this restriction was necessary. The Resolve Viewport Field Top Left Position utility function determines the top left position of the playing field, based on the field size and viewport tile size. The Render Playing Field method was then updated to draw the playing field dynamically based on the field size. All other drawing methods also needed to be updated to draw their sprites based on the dynamically calculated viewport. On the Quick Game Options menu, we'll need 2 additional sliders for the field width and field height. The Splash Quick Game Options menu ID and Splash Quick Game Option Values namespaces were updated to include constants for these. Similar constants were added to the Splash Quick Game Options menu labels namespace for the display labels. The Create Field Width menu item and Create Field Height menu item functions are used to build the slider menu items. And these are added in the Create Quick Game Options menu definition map function. In the Splash Scene Controller constructor, the slider values are initialized according to the defaults. And to cap things off, the Get Quick Game Options method is updated to set the field size to the slider values. With everything wired in, we now have our functioning field size options in the menu. We can play with any crazy field size we want. Even a huge field that makes our snake look like a tiny little earthworm. The final gameplay option we'll add is how much the snake will grow when eating an apple. We'll first need to update the Quick Game Definition struct to include snake growth as a parameter, and add an internal variable to the Quick Game class for it. When we detect that the snake has eaten an apple in the Quick Game's update method, we now increase the queued snake growth by this amount. The Quick Game Options definition struct is updated to include the snake growth. At this point, I decided that the default of 2 seemed a bit low, so I increased it to 3. In the Quick Game Controller's start game method, we can now initialize the snake speed based on this value. To add the snake growth as a slider, we have the new Create Snake Growth menu item function. As with the other sliders, it uses a new set of constants for the menu IDs, labels, and value ranges. And we update the Splash Scene Controller constructor and its Get Quick Game Options method as we did with our other options. And here we see our final game option in action. Some seriously beefy apples to make our snake grow really fast. The next 2 tasks involved adding a System Options menu to adjust the music volume and the sound effects volume. We'll look at the code changes for these together, as they're very similar. First, we add a new System Options definition struct, setting the default volume to full at 100. We add another set of menu identifier and slider value constants for the new System Options menu, along with constants for the display labels. The Create System Options Menu Definition map function builds the new menu, with separate menu items for the music and sound volume. The splash scene controller constructor initializes the slider values with the defaults. The new getSystemOptions method will be called by the GameClient class when it needs to communicate the volume values to the game. When processing events, we add another case for the new Systems Option menu in all the places we might expect. The one extra thing we need to do is update the splash scene's music volume in real time as the player adjusts the slider value. On the new Quick Game controller, we have a new setSystemOptions method which is called by the GameClient when the player starts the game. Anywhere that we start playing music, we first set the volume accordingly, and we do the same with the sound effects volume. The final menu option allows the player to switch between windowed and full screen mode. For this, we're finally going to make use of the button options menu item type. We start by adding the menu identifier and value constants for the available video modes. The Create Video Mode menu item function is used to create the menu item. On the splash scene renderer, we support the drawing of button options with the new Render Menu Item Button Options method. This first determines the position of the leftmost button. Then it loops through the available button options and draws each in turn, ensuring the current value is drawn with yellow text to indicate focus. The Resolve Button Options Width method is used to determine the full width of all button options for a menu item. For user interaction, we also update the Resolve Menu Mouse Position Result method to handle button options. The result includes additional properties to indicate which button option the mouse cursor is over. In the splash scene controller constructor, we initialize the video mode to the default of windowed. And in the process left mouse button pressed event, we return a client request indicating which video mode the player wants based on the button option they clicked. The final piece is in the process splash scene event method of the game client. Here we handle switching between a window or full screen mode. SFML provides the special getDesktop mode method to make the switch to full screen easy. And here we are, toggling between a window and full screen. We now have all the game options and system options a player could expect from our simple little snake game. From here, I did continue on with some improvements to the quick game mode before moving forward with story mode. One of the main fixes involved creating an input queue for snake control. The game initially only kept the most recent key press for processing the next time the snake was to move forward. If the player turned twice very quickly, this would cause it to only register the most recent key press. Adding an input queue solved this by ensuring both key presses were processed in the proper order. This concludes the game development series for the Garden of Eden quick game mode. If there turned out to be any demand for it, I would consider putting together episodes for some of the features introduced in story mode. Links to the full game can be found in the description below.